So we would like to compute a vector line integral of this vector field that is implied by the integral expression along the unit circle traversed in the counterclockwise way. And let's recall the formula. So the formula for the integral of p dx plus q dy along C is simply the integral from a to b of f of r of t dot r prime of t dt, where f is simply the vector field pq, and r of t is a parameterization of C compatible with its orientation. Okay, so we have the unit circle, and the parameterization that is compatible with the counterclockwise orientation is quite standard: cosine t, comma sine t, for t between 0 and 2 pi. And the velocity that we're going to need here is obviously negative sine t, comma cosine t. Now, let's try to understand what the underlying vector field is. And we have to pay a little attention here because, look, the Leibniz notation for vector line integrals allows us to the flexibility of actually putting dy first and dx second. And whatever is sitting in front of dx, that will be the first component. Whatever is sitting in front of dy, that will be the second component, which means that the underlying vector field here is minus y over x squared plus y squared, comma x over x squared plus y squared, and not the other way around that one would have come up with if naively one looked at the order in which those components appear in the integral expression. Okay, so now what is f of r of t? In other words, what are we going to get if we replace x by cosine t and y by sine t? This is what we should do. And what we're going to get is minus sine t over cosine square of t plus sine square of t, comma cosine t over cosine square of t plus sine square of t. So you see that the denominator is very, very simple thanks to the Pythagorean theorem. So cosine square of an angle plus sine square of the same angle is 1. So we simply get negative sine t cosine t. So now we need to just take this dot product, right? So we have that f of r of t dot r prime of t is negative sine t comma cosine t dot negative sine t comma cosine t, which is sine square of t plus cosine square of t, which is equal to 1. So after all these identifications and interpretations, we end up with a very simple integrand which is equal to 1. So all we need to do is integrate this over the interval of the parameterization, and that will give us 2 pi. And that's it. Thanks for watching.